Hi, welcome to this lesson on trigonometry, compound angles. Let's have a look at question 8. With the use of a diagram, we want to find the following trigonometric ratios, and then we want to solve these two questions. So I'm going to simplify each one here. If I add 3 and then divide by 5, I get cos alpha equals 3 over 5. And then for my cos diagram here, cos is positive in the first and fourth quadrants, but we're also given that it must be between 0 and 180, so it could either be the first or second quadrant. So where they overlap is the first quadrant. Then, for this one here, if I add 12 and then divide by 13, I get sine beta equals 12 over 13. And again, sine is positive in the first and second quadrants, but because I want it between 90 and 270, that means it could either be over, so greater than 90 and less than 270 is going to be second or third quadrants. So where they overlap is the second quadrant. Okay, so let's go ahead and draw those there. So cos alpha equals 3 over 5. Okay, so cos alpha equals 3 over 5. And we know it's in the first quadrant. So there's your angle alpha. And cos is adjacent over hypotenuse. So the adjacent length here must be 3 units. So therefore, if I call this point P, the x-coordinate is 3. And the hypotenuse length, which is always a positive number, is 5. So if I use the Pythagorean theorem to solve for this length here, let's call it y, then I have 3 squared plus y squared equals 5 squared. So y squared is equal to 25 minus 3 squared, which is 9. So I get 16. So y is equal to plus or minus 4. But because y is in the positive part here in this quadrant, that coordinate is going to be 3, 4 there. Okay, so y equals positive 4. Next we had sine beta equals 12 over 13. So sine beta is 12 over 13. And it was in the second quadrant. Okay, so there's the points up there. Now the angle beta is this angle here. Okay, and then sine is opposite over hypotenuse. So this magnitude length here is 12 units. So if I call this point Q, then the y value is 12 here. And the hypotenuse is 13. So if I look for this x value here, I get x squared plus 12 squared equals 13 squared. So x squared equals 169 minus 144, which is 25. And then taking the square root on both sides, we get x's plus or minus 5. But again, from the analytical geometry standpoint, we are on the negative x-axis. So this is negative 5, comma 12. Okay, so now that we have all the information regarding these triangles in the plane, we can go ahead and answer some questions. So cos beta minus alpha. So it's going to be cos, sine, for the compound angle formulae. And then it's going to be beta alpha, and because of the minus, it becomes plus. Okay, so what does that equal to? Well, cos of beta, let's go back to the diagram. Cos of beta, that's adjacent, which is negative 5, over hypotenuse, which is 13, times cos of alpha, which is 3 over 5 we were given, plus sine of beta was 12 over 13 given, and then sine of alpha, that's going to be opposite over hypotenuse, which is 4 over 5. So what do we have? Negative 5 times 3 is negative 15 divided by 5 times 13. So that's going to be 50 and 15, so 65. Then over here we have plus 12 times 4 is 48 over 65. And if we add those, so 48 minus 15 over 65, that gives you 33 over 65. Yeah. Okay, and then for this one here, tan of alpha plus beta, well, we can rewrite that as sine of alpha plus beta divided by cos of alpha plus beta. Because we didn't derive a compound formula for tan, although we actually can derive one, right? It's not necessary at this point, and we'll just use sine and cos. Okay, so in the numerator, that expands to sine alpha cos beta plus cos alpha sine beta. And then in the denominator, we have cos alpha cos beta minus sine alpha, sine beta. Okay, so now we just have to carefully plug in the values and then go ahead and solve. So sine alpha, we did actually have that, right? It was 4/5. We worked it out. Cos beta, we worked that out. That was -5/13. Plus cos alpha is 3/5 times sine beta, which is 12/13. Okay, that's the numerator. And the denominator, cos alpha is 3/5 times cos beta, which we worked out was -5/13, minus sine alpha, we worked out, and it was 4/5 times sine beta, which is 12/13. Okay, now we just need to work out. So let's do the numerator first and the denominator. So we're going to have -20/65 for the first term, plus 36/65. Then in the denominator, we're going to have -15/65 minus, it's going to be 48/65. So at this point, I would just plug into a calculator and go ahead. We've shown enough algebraic working out. So let's go ahead. So in the numerator there, so I'm just going to set up this fraction so long on my calculator. So for this one here, it's -20/65. And it was plus on the top, and then it was 36/65. Okay, and then over here we're going to have -15/65. All right, and then 48/65, and that is a minus in the middle there. Okay, and we get -16/63. All right, so the denominator has actually changed, which is interesting. So after all the simplification, it must have boiled down and simplified. Okay. All right, so we've used all the correct trigonometric ratios. We did our diagram correctly, and we expanded using the compound angle formulas. All right, I'll see you in the next one.